This printer is based on the SLM technology. It's a metal printer where you have a very fine powder that you melt together with a laser in very thin layers. So you get the geometrical freedom because you just have a drawing on your computer and then put it into very thin slices and build up your part from these thin slices. Printing in the metals, stainless steel, tool steel, titanium, aluminium, then you get some new possibilities. You can actually use it for products and not just prototypes. So many of the parts that we print are actually for production and parts going into a final product.
When you look at 3D printing, it often involves powder materials. And of course it starts with that you have to load your powder into the 3D printer. So this is the first step where you have to be aware of that there is a potential risk of exposure. And then of course you have the specific printer job where the substance are applied and you construct your 3D print. And during these conditions you can of course ventilate the equipment so you don't get potential release into the working area that you have established your system in. And then after the printing process you have a phase where you need to collect your item that you have been printing, and in that case you have to access your printer job, and again here you have a risk of particle exposure. And following that step you might have a refining process where you either blow excessive dust off your material, you put it in a sinter oven, or you have to do sandblasting or another high energy process to shape your material. And in this case you also have a risk of particle exposure and might want to apply enclosure and so on. And finally you also have a possibility to retrieve your powders that you applied in the printing process, refine it and reuse it. And in these cases you will normally go through a sieving process, and in this case you again have a normal exposure situation with the sieving that we know is a dust generating process, and you again have to try and protect yourself for inhalation exposure.
There are some issues regarding health and working environment. Since it's a powder, very fine powder, you get inhalation possibility, so you need to wear masks when you handle the machine and handle the powder. Also you need to wear gloves so you don't get it on your skin.
To protect yourself against inhalation risk or dermal exposure risk is of course to apply the ventilation rules, that you try to ventilate the area that you work with. If you work with low toxic compounds, it might be sufficient to work with local exhaust ventilation. But if you work with higher toxic compounds, you may need to have a specific ventilation addressing these higher toxic materials, and you might even have to apply personal protection gear that is of very high quality. And for dermal protection, long gloves is usually a good way to protect yourself, or double gloves is another possibility. Wear lab coats and try not to spread your particles into the environment where you work. And this is especially important with chemicals such as nickel, where you have a contact allergy and so forth that can be related to the material.
In the 3D print market we see very rapid development at the moment. For the smaller printers, there were sold about 140,000 in 2014, according to Voller's report, which is an annual report on the 3D market. So 140,000 of these going into hobby enthusiasts, offices, garages, wherever they want it. Also a lot of schools, small development houses are buying these small printers. And you can buy it off the internet for a few thousand crowns, and just collect it at home, buy some material also off the internet and install that on your printer. For the bigger machines, the more industrial machines that we have here, of course you get some more guidance when you buy these machines, so the most important thing is to follow the recommendations from the manufacturer. These machines, I think they were sold about 14,000 in 2014, according to the same report. And for the metals machines, it's only a few hundred that are sold each year. But the progress that we see at the moment, both for the industrial machines, also for the hobby machines, is a doubling each year. So in a few years, there's going to be a huge number of the machines on the market.
When we talk about low-cost 3D prints, which are often applied in education and so on, you again have to be a little bit aware about what you're doing. You have to try and see if you can establish local ventilation in the workrooms where you are, in the classroom, where you demonstrate 3D printing. At this point, we actually don't know exactly what is the exposure during these incidents, but as a general rule, it's always important to try and avoid exposure to the pupils in the room and the teacher himself, of course.